Hi, okay, so welcome to our reference table E, quick 5-minute video on how you're going to use reference table E. So mostly you're going to use reference table E when you're writing formulas or you're naming formulas. So going from the formula to the name, like we have over here on the left-hand side, and over here on the right-hand side where we go from the name to the formula. So I've got a couple of examples that I've started for you. So just try to follow along. So this is not going to be an introductory lesson on how to write and name formulas. This is to be something that you're going to use for review and reinforcement. So the first one, I'm given a formula. I'm given the formula KCN, and I need to come up with a name. So the first thing you do is you're going to look, I have more than 2 elements. Anytime you have more than 2 elements, you're going to need table E. Because remember, an element can only have 1 capital letter. Compound, minimum of 2 capital letters. And if you have 3 capital letters, you're going to have something from reference table E. So I need to find something, either KC or CN, that's going to be a polyatomic, because poly means more than 1. So I'm going to search this table. I don't see anything with KC, but I do see a CN, right? I find that the CN is over here, and that's the cyanide. Okay, so the CN is the cyanide ion, right? An ion is that because it's negatively charged, right? These all have charges. That's what makes them an ion. So then what I'm going to do is I always name the metal first. So potassium for K. And if you're not sure what the symbol in the name is, you're going to use reference table S to get the name for K. So that's potassium. So P-O-T-A-S-S-I-U-M. And now I'm going to name the polyatomic ion, which is this CN piece. I'm going to name it exactly as it appears on reference table E. So then, and that is cyanide. So C, cyanide. All right, so now KCN, potassium cyanide. So then now let's go and take a look at, so now I have this Cu and I have this OH. Anytime you've got something in parentheses, you automatically know what's in parentheses is going to be the polyatomic ion. Parentheses starts with P, polyatomic starts with P, right? So I have to find the polyatomic. So that's over here, that's hydroxide. So then that's what I'm going to name that. Now I need to find the name of this metal, and that's going to be copper. Cu later, copper. But again, I can find Cu on table S, and I can find the word that matches. So this is copper. And then now I'm going to name hydroxide. Well, copper is really special. Copper happens to be in the transition metals of the periodic table. To save time, I only have 5 minutes on this video. I'm not going to go to the periodic table. But copper has multiple oxidation states on the periodic table. It can be a +1 or it can be a +2. So I can't just say this is copper hydroxide because I don't know what the ratio between the copper and the hydroxide. I need to convey that in my name, right? So in KCN, potassium can only be +1 and cyanide can only be -1. So I don't need any other identifying information about potassium or cyanide. But in copper's case, copper can be +1 or minus, or +1 or +2. I have to give it some way of giving it, more meaning. So I need to use a Roman numeral. And if this copper is a +1, I use a Roman numeral 1. If the copper is a +2, I'm going to give it a Roman numeral 2. So I don't know. I have to look at this formula and figure out what the oxidation state of this copper is. I need to use some math, right? You always know the charge of the negative ion, right? So right over here, right? The hydroxide is a -1 charge. Right, the sum of the oxidation states has to equal 0 because all compounds are electrically neutral. The positives equal the negatives. So if I have 2 -1 hydroxides, my total negative charge is -2. I'm just writing these numbers on top just to keep track. So that means that that 1 copper has to balance that out and cancel that out to add up to 0. So what positive number is going to add up to 0? It's going to be +2. So Roman numeral 2, right? So now let's go over here to the other side. This copper, Roman numeral 2, tells me that this copper is a +2. So when I do this, I do symbols, copper, and now I do the sulfate, which is SO4, right? I find that right over there on the table, put my polyatomic ion in parentheses. So copper +2, and then the SO4